I'm the author of Spatula. It's a simple parametric tool for action synthesis, and it is a tool that is different in spirit than Imitator or Romeo, as it uses binary decision diagrams to represent the state space. Now, there are some downsides of having the state space represented using binary decision diagrams and some advantages of that. The main advantage is that binary decision diagrams can preserve really huge models in the memory of a computer. The disadvantages is that it's really not very efficient to manipulate single states. So we can have fixed point computations that work on sets of states, or in this case on functions, but we should really not play with singular states. Now, Spatula uses a simple C-like language to describe models. We will go through the description of a single model and describe some of its features. Okay, so we firstly declare the model as a module and its name. Then we emerge states using some of standard control flow statements. In this case, we emerge 4 states, S0 to S4, using the command bloom. This is this one. And we mark the initial state, this state, using a command mark with. Then we mark the remaining states as P or safe, as needed. And we join some of the states using transitions and the command join with. Join with needs a source, target, and the action name. Finally, we write down the formula to be verified, and this formula, in this formula, hash signifies the modality. In this case, this is exists a future, and the $sign stands for precedes the variable. Okay, so to run Spatula, we simply call Spatula with a switch F and the name of the file. And in the case of some models and some modalities, we can also try minimalization of the set of actions under which this formula holds. This is done using prime implicants, which is a technique most used in electronic engineering. And so in this case, we can ask what's the minimal y under which safe can be reached from the initial state. And well, the answer is this is actually the core of all these sets is Act 2. This needs to be present in every set of actions that allows to reach safe. Okay, this concludes the brief description of Spatula. And finally, to conclude, you now know the basics of parametrics in Petri nets and in mixed transition systems, and you have been introduced to Romeo and Spatula. We now move to the practical session, but before that, we would like to thank the organizers and especially Fabrice Cordon for making all this possible. Thank you.